Welcome to the peaceful space of sleep-friendly science, where we gently drift beyond our world to ponder a universe where the fundamental building blocks of life might be entirely different. Here on our planet, carbon is the undisputed king, the very blueprint of all we know as life. But as we gaze into the cosmic dark, we wonder, could there be other blueprints? Could life, in some strange and beautiful form, arise from silicon or elements we've barely considered? Now settle in, take a deep breath, and let the soft sounds guide you as we begin tonight's journey into the unknown. Section 1. The Carbon Tapestry. Before we journey to the swirling seas of methane on Titan, or the crystalline landscapes of a world we can only imagine, let us begin our exploration here, in the quiet sanctuary of your own being. Feel the gentle rise and fall of your chest, a slow and steady rhythm like the tide. Each breath you take, each beat of your heart, every fleeting thought that drifts through your mind like a cloud, is part of a story. It is a story written in a single, extraordinary language, the language of carbon. On our world, life did not choose its foundational element at random from the cosmic pantry. It settled upon an atom of almost indescribable grace and versatility. An element so fundamental, so deeply woven into our existence, that we often forget it is there at all, much like we forget the air we breathe. This is carbon, the quiet architect, the humble sovereign of all known biology. Imagine, if you will, the periodic table of elements not as a sterile chart in a classroom, but as a grand kingdom of cosmic personalities. There are the volatile nobles, the explosive gases flaring with energy. There are the heavy, stoic metals, dense and ancient. And then there is carbon. It is not the flashiest, nor the loudest. It is the diplomat, the connector, the artist. Its genius lies in its sociability. At the heart of this genius is a simple, elegant number, 4. Carbon has 4 electrons in its outer shell, which means it has 4 empty spaces, 4 open hands reaching out into the universe, ready to connect. It yearns to form 4 bonds, to create stability by sharing itself with others. Think of it as a perfect cornerstone, able to build not just in a line, but upwards, downwards, and outwards, creating 3-dimensional structures of breathtaking complexity. While other elements might form a simple chain, carbon builds cities. It constructs cathedrals of molecular architecture. Within your own body, at this very moment, this cosmic dance is taking place trillions of times over. Carbon atoms are holding hands with other carbon atoms, a phenomenon known as catenation. They form long, shimmering chains like the fatty acids that store energy, molecules of pure, slow-burning sunlight captured from a summer long past. They curl into graceful rings, forming the fragrant compounds in a flower's perfume or the fundamental structures of your own DNA. These are not just chemical bonds, they are promises. They are the threads from which the great tapestry of life is woven. And look at the partners it chooses. It bonds with oxygen and hydrogen to form the sugars that fuel your thoughts as you listen to my voice. It links with nitrogen to create the amino acids, the pearled beads that twist and fold into the intricate, miraculous machines we call proteins, the enzymes that digest your food, the hemoglobin that carries life-giving oxygen in your blood. Carbon is the ultimate collaborator. It is the lead dancer that invites everyone onto the floor, organizing them into a symphony of function and form. The strength of these bonds is another piece of its quiet perfection. A carbon-carbon bond is a marvel of just right engineering. It is strong enough to be stable, to build the enduring framework of a tree or the delicate scaffolding of a cell. Yet, it is not so strong that it cannot be broken. Life is not a static monument. It is a current, a flow of energy. For you to live, to dream, to heal, these carbon bonds must be gently unclasped to release the energy stored within them. It is a bond strong enough to build a castle, but gentle enough to allow its doors to be unlocked when needed. This perfect balance between stability and reactivity is one of the deepest secrets to life's success on Earth. Let your mind drift back, further and further, beyond your own life, beyond human history, to the very beginning. Where did this miracle atom come from? It was not forged in the Big Bang. The early universe was a simple place, filled mostly with hydrogen and helium, the two lightest and simplest elements. Carbon is a child of the stars. Picture a star far larger than our sun, living its magnificent, fiery life over billions of years. In its core, the pressure and temperature are so immense that the laws of physics begin to dream. Atoms are crushed together, forced to fuse in a process of cosmic alchemy. Hydrogen becomes helium. Helium atoms, in turn, are fused together to become beryllium, and then, in a delicate and crucial step called the triple alpha process, a beryllium atom and a helium atom fuse to create a single, perfect atom of carbon-12. An atom with 6 protons, 6 neutrons, and those 4 beautiful, sociable electrons in its outer shell. For eons, this carbon was locked away in the heart of a star. But stars, like all things, are mortal. When this giant star reached the end of its life, it died in a spectacular explosion, a supernova. In that final, glorious cataclysm, it seeded the cosmos with the treasures it had forged in its core. Trillions of tons of carbon, along with oxygen, nitrogen, and all the other heavy elements, were blasted out into the interstellar void. They drifted for ages as clouds of glittering dust, cosmic ghosts. They swirled and cooled, eventually drawn together by gravity to form new stars and new planets. Our planet, the Earth. The iron in your blood, the calcium in your bones, and the carbon that forms the very vessel of your consciousness, it was all born in the heart of a dying star. You are, in the most literal sense, woven from stardust. You are the universe's way of taking a handful of its own ashes and breathing life and wonder and dreams into them. This is the story of carbon, the story of its 4 open hands, its talent for building chains and rings, its perfectly balanced bonds, and its stellar origins. It is the element that makes a forest, a whale, a single blade of grass, and you. It has created a form of life that is resilient, adaptable, and beautiful beyond measure. And so, as we lie here, cradled in this carbon-based world, a question begins to whisper at the edge of our minds, a question as vast as the night sky itself. Is this the only way? Is carbon the only artist capable of painting the masterpiece of life? Or, in the deep, unexplored corners of the cosmos on worlds that circle alien suns, has another element, another quiet architect, been given a chance to build its own reality? Is there a different dreamer, a chemical cousin to carbon, waiting to tell its own story? Section 2. The Silicon Dreamer. As you rest here, cradled in the familiar embrace of our carbon world, let your imagination drift to that grand cosmic kingdom of the elements we pictured. If carbon is the reigning sovereign, the celebrated artist of life, then just one step below it on the periodic chart lies its closest relative. Its younger sibling. Its shadow. An element that shares so much of carbon's promise, yet walks a profoundly different path. This is the Silicon Dreamer. You know silicon intimately, even if you do not know its name. Feel, in your mind's eye, the warmth of beach sand trickling through your fingers. Picture the sharp, cool beauty of a quartz crystal, catching the light in 1,000 tiny rainbows. See the majestic face of a granite mountain, ancient and unmoving. This is the kingdom of silicon. Here on Earth, it is not the stuff of life, but the stuff of landscape. It is the stage, not the actor. And yet, for over a century, scientists and dreamers have looked at silicon and whispered, what if? The source of this whisper, the heart of this dream, is that same elegant number, 4. Like its older sibling carbon, silicon sits in the same column on the chart, which means it also has 4 open hands for electrons ready to form 4 stable bonds. It holds the same fundamental architectural potential. In theory, it too could be a cornerstone building complex, 3-dimensional molecules. It could, in principle, create its own version of life's cathedrals. It is the most abundant solid element on Earth, a ready and waiting supply of bricks for a different kind of biological creation. The potential is so tantalizing, so close, you can almost taste it. So why? Why, on a planet made of silicon rock, did life choose the far rarer carbon? Why is our world a soft, green, carbon-based jewel set within a hard, silicon-based casket? To understand this, we must look closer at the nature of silicon's bonds, at the promises it makes. Imagine again those chains that carbon forms so effortlessly, the long, stable backbones of fats and proteins. When silicon tries to do the same, linking hand in hand with other silicon atoms, it forms chains called silanes. But the silicon-silicon bond is weaker than the carbon-carbon bond. It is more brittle. If carbon atoms form a chain of interlocking, flexible steel, silicon atoms form a chain of glass. It is beautiful and it can be long, but it is fragile. A little too much energy, a little too much heat, and the chain shatters. The long, complex molecules needed to store information or build resilient structures would be in constant peril of falling apart. Life needs a foundation that can bend without breaking. But the true challenge, the great obstacle that turns silicon's dream into a near impossibility on a world like ours, comes when it joins hands with oxygen. As you lie here, you are performing this chemistry with carbon. You breathe in oxygen, and in the quiet furnaces of your cells, you combine it with the carbon from your food. The result is carbon dioxide, CO2, a gas. A weightless puff of air you return to the world with every exhale. It dissolves in the oceans. It is taken up by the leaves of trees. It dances invisibly in the atmosphere. It is a perfect, ghostly messenger, allowing the cycle of energy to flow without impediment. It is a waste product that simply floats away. Now imagine a silicon-based creature. Imagine it performs a similar metabolism, taking in energy and exhaling its waste. When silicon bonds with oxygen, it does not create a ghostly gas. It creates silicon dioxide, CO2. You know it as quartz, as sand. Picture it. With every breath, this creature would exhale a microscopic grain of rock. Its lungs, or whatever passed for them, would slowly fill with cement. The channels that carry its lifeblood would clog with grit. The very act of living, of processing energy, would be an act of slow self-petrification. How could a global ecosystem function if its waste product was not a fleeting gas, but solid stone? The cycle of life would not flow. It would grind to a halt. The planet would become a desert of its own biological exhaust. On a warm, wet, oxygen-rich world like Earth, the choice was clear. Life chose the element whose ashes could be given to the wind. Does this mean the Silicon Dreamer story must end here? A failed experiment, a chemical dead end? Perhaps not. We must remember that we are judging silicon by the rules of our own world, by our standards of temperature, pressure, and chemistry. To truly explore the possibility of silicon life, we must leave our world behind. We must become aliens ourselves, and journey to a place where the rules are different. Let us imagine a world very different from Earth. A world that is bitterly, profoundly cold. On such a world, the weak, glassy bonds between silicon atoms would become far more stable. The gentler energy of a cold environment might be the perfect nursery for these fragile chains to grow long and complex without shattering. The slow, deliberate chemistry of the cold might favor silicon's nature. And what of the oxygen problem? Perhaps the answer is to imagine a world with no free oxygen at all. Many worlds in the cosmos are like this. They have what are called reducing atmospheres rich in hydrogen and methane. In such a place, silicon would never be tempted to form solid rock. Instead of bonding with oxygen, it might bond with hydrogen, forming those silane chains we mentioned. And the fundamental unit, silicon with 4 hydrogen atoms, is silane gas, CH4. It is the silicon equivalent of methane, CH4. A gas that could play the same role in a silicon world's atmosphere as methane and carbon dioxide do in ours. So now a new picture begins to form in our minds. We are no longer on Earth. We are on a frozen world orbiting a dim, distant sun. The temperature is so low that nitrogen itself lies in frozen pools. In this strange, frigid landscape, something is stirring. It is not soft or warm or fleshy. It looks perhaps more like a crystal than a creature. Its body is a complex, ordered lattice of silicon. It moves with geological slowness. A single thought might take a century to ripple through its crystalline mind. Its life is not measured in years, but in millennia. It does not breathe oxygen. The very touch of it would be a violent poison, turning its delicate form to stone. Instead, it might breathe hydrogen, and its slow, cold metabolism would run on chemistry we can barely comprehend. The senses would not be like ours. It might not have eyes to see light, but instead might feel the subtle vibrations of the planet's crust, or sense the shifting of magnetic fields. It would perceive the universe not as a flow of images and sounds, but as a slow symphony of geological time, of pressure and structure. Is this pure fantasy? Perhaps, but it is a fantasy guided by the quiet whispers of chemistry. It tells us that while carbon may be the undisputed king on this world, the universe is vast and endlessly creative. The failure of one chemistry in one environment might be the roaring success of another in a different, stranger place. The rules of life might not be as rigid as we think. And this journey to a cold, silicon world raises another, even deeper question. The problem of solid waste was solved by imagining a different atmosphere. But both carbon life and our hypothetical silicon life still rely on a liquid to function, a medium where molecules can swim, meet, and react. For us, that liquid is water. It is the river of life. But on a world cold enough for silicon beings, water would be a solid block of ice, as hard and lifeless as granite. If life is to exist there, it needs another river, a different solvent, a sea made of something else entirely. Section 3: Worlds of Liquid Methane. The story of the Silicon Dreamer leads us to a profound realization. The stage on which life performs is just as important as the actor itself. We imagined a cold world to stabilize silicon's fragile bonds. But in doing so, we froze the very river of life as we know it, water. On a world cold enough for silicon to thrive, water becomes a rock, a mineral, as inert and unmoving as granite. So the question we were left with, a question that now hangs in the quiet air around us, is what could possibly take its place? What could be the solvent for a truly alien biology? Let the anchor of Earth's familiar chemistry slip away. Allow your mind to drift outwards, past the orbit of Mars, past the great belt of asteroids, to the realm of the gas giants. Here, in the court of Saturn, the ringed king circles a moon that holds the answer. It is a world shrouded in a thick, golden-orange haze, a perpetual twilight veil that hides its surface from prying eyes. This is Titan, and it is, perhaps, the most alien yet hauntingly familiar world in our solar system. If you were to descend through Titan's atmosphere, you would find it strangely comfortable in some ways. The pressure is just a little higher than Earth's, gentle and encompassing. The atmosphere itself is mostly nitrogen, just like our own. But here, all similarity ends abruptly, shattered by a cold so profound it feels less like a temperature and more like a fundamental state of being. It is nearly 180 degrees Celsius below zero, a cold that would freeze the very air you just exhaled into a solid frost. It is in this impossible cold that water is transformed into stone. The mountains on Titan, the bedrock, the very pebbles on the shore, they are all made of water ice, hard as rock. And on the shores of these ice mountains, something incredible is happening. There are lakes, there are rivers, there are vast and tranquil seas. But they are not filled with water. They are filled with liquid methane and ethane, the very substances we know on Earth as natural gas. The fuel that heats our homes and powers our stoves exist on Titan in a liquid state, pooling in depressions, carving channels, and creating a landscape of impossible beauty. Here, a different river flows. Could this be the solvent we were searching for? Could life swim in these frigid, hydrocarbon seas? To answer that, we must understand what makes water so special here on Earth. Water is a magical molecule. It is polar, meaning it has a tiny positive charge on one end and a tiny negative charge on the other, like a miniature magnet. This polarity makes it an incredible solvent. It lovingly pulls apart salts and other polar molecules, surrounding them, allowing them to move and react. It also gives rise to the hydrophobic effect, the tendency for oily, nonpolar molecules to clump together to get away from water. This very effect is what creates the membranes of your cells. Your cells are essentially tiny bubbles of oil, their skins held together by their mutual dislike of the water that surrounds them. Now, let us return to the dark, still seas of Titan. Methane is the opposite of water. It is nonpolar. It has no charge, no magnetic personality. If water is a powerful magnet, methane is a smooth, polished stone. It doesn't pull. It simply surrounds. Things do not dissolve easily in it. The intricate dance of chemistry that water facilitates with such ease would grind to a near halt in liquid methane. A chemical reaction that takes a split second in the warm, watery environment of your cells might take 1,000 years to occur in a methane sea. So, at first glance, it seems hopeless. But life is endlessly clever. It does not surrender to its environment. It adapts to it. Perhaps life on Titan would not be built from the same polar molecules that we are. Perhaps it would be built from nonpolar molecules, things that are perfectly comfortable in a methane bath. And what about a cell? How could you form a membrane, a bubble of self, in a nonpolar sea? The answer is as elegant as it is alien. You would have to turn the cell inside out. Here on Earth, our cell membranes have heads that love water and tails that hate it, so they form a double layer with the water-hating tails tucked safely inside. In a methane sea, a cell would need a membrane with a head that loves methane and a tail that hates it. The result would be a bubble of life with its skin inverted, protecting a unique, perhaps watery or ammonia-filled interior from the methane sea outside. Scientists have even given this hypothetical structure a name: an azotosome, a nitrogen-based body, perfectly at home in the alien liquid. Let your mind paint a picture of this life. The sun is a distant, pale disk in Titan's hazy sky. There is not enough light for photosynthesis as we know it. So this life would not be powered by sunlight, but by chemistry. The thick atmosphere is rich with complex molecules, like acetylene, which rain down constantly from the upper layers where sunlight does stir up chemical reactions. Perhaps the creatures of Titan's seas would be chemosynthetic. They might breathe in the acetylene that falls from the sky like a fine, energetic dust, react it with hydrogen gas seeping from the moon's interior, and release energy. They would be living, breathing chemical engines, fueled by the very sky above them. And this life would be slow. In the profound cold, every chemical reaction, every movement, every thought would be unhurried, unfolding over vast stretches of time. Life here does not sprint. It crystallizes. A creature might lie dormant on the sea floor for a decade, gathering the energy for a single movement. It would not know haste. It would perceive time on a geological scale. It might communicate not with sound, which travels differently in methane, but through the slow release of chemical signals, a conversation that could last for centuries. Imagine it now, a vast, dark, silent being, more like a living reef than an animal, its inverted cells functioning in the unimaginable cold. It is drifting through the cold, dark liquid of a sea of natural gas, beneath a sky of orange smog. The mountains on the shore are made of frozen water. It is a world built from paradoxes, a place where our poison is their ocean, our rock is their mountain, and our fuel is their water. The lesson of Titan is a lesson in humility. It teaches us that our definitions are provincial. What we call cold is merely a different energy state. What we call a gas can be a liquid. It forces us to question the most fundamental assumption of all. that life needs water. By imagining a world where the river of life is made of methane, we open our minds to possibilities far beyond our own reflection. But our journey into the strange chemistries of the cosmos has just begun. We have explored a world that replaces our central element, carbon, with its cousin, silicon. We have visited a world that replaces our essential solvent, water, with liquid methane. But both of these still rely on a similar principle. A single element forming the long chain, the backbone of life. What if that too is not a universal law? What if we could build a chain of life not from carbon, or even from its cousin silicon, but from two different elements, woven together in an alternating pattern, creating a structure entirely new to our imagination? Section 4. The phosphorus-nitrogen chain. Our journey so far has followed a certain logic. We took carbon, the foundation of our being, and swapped it for its closest chemical sibling, silicon. We took water, our river of life, and replaced it with a frigid sea of methane. But in both these imaginings, we held on to one core assumption, that the backbone of life, the long chain upon which all complexity is hung, would be made of a single element repeating itself, hand in hand into infinity. Carbon with carbon, or silicon with silicon. Now, as you drift deeper into the quiet of the cosmos, we must ask a more radical question. What if life's central thread is not a chain, but a braid? What if it is woven from two different elements, alternating in a dance of perfect partnership? To imagine this, we must call two new elements to the stage of our minds. You know them both. One is nitrogen. It is the most common gas in the air you are breathing right now, an immense, invisible ocean in which we live. Nitrogen on its own is famously aloof. A molecule of nitrogen gas consists of two atoms locked in a triple bond, one of the strongest bonds in chemistry. They are so content with each other, so self-sufficient, that it takes an enormous amount of energy to pry them apart and make them react with anything else. Nitrogen is the quiet stoic, the stable, reserved foundation. His partner in this hypothetical braid is phosphorus. Phosphorus is nitrogen's close relative, sitting just below it on the periodic table. But its personality could not be more different. Where nitrogen is stable and reserved, phosphorus is eager and reactive. In its pure form, it can burst into flames simply by touching the air. On Earth, phosphorus is the energetic messenger of life. It forms the backbone of our DNA, and it is the key atom in the molecule ATP, the universal energy currency of our cells. If nitrogen is the calm, deep ocean, phosphorus is the flash of lightning that strikes its surface. Individually, they seem ill-suited to form a long, stable chain. Nitrogen is too content on its own. Phosphorus is too volatile, too ready to react. But what if they could be convinced to join hands not with themselves, but with each other? In a repeating pattern, a phosphorus atom, then a nitrogen, then a phosphorus, then a nitrogen. A chain of two interwoven souls. Chemists know the structure. It is called a polyphosphazine, and it has remarkable properties. This alternating PNPN backbone is incredibly flexible, more like a strand of rubber than a rigid crystal. It is also surprisingly strong and stable. The fiery reactivity of phosphorus is tamed by the steadying influence of nitrogen. The aloofness of nitrogen is given purpose and connection by the versatile phosphorus. Together, they create something that neither could achieve alone. It is a true chemical partnership. And here is where the true beauty lies. The nitrogen atoms in the chain are the stable links, holding the braid together. The phosphorus atoms, however, are the points of creativity. Like carbon, phosphorus can form multiple bonds, reaching out to connect with other atoms and molecules. You can attach an immense variety of side groups to the phosphorus atoms along this chain. This means a phosphazine backbone could create the same kind of staggering complexity we see in carbon-based proteins. You could have one side group that repels a certain molecule and another that attracts it. You could have a side group that acts as a catalyst and another that carries a piece of information. You would have a long, flexible, stable backbone, the perfect molecular scaffolding on which to build a creature. But like the silicon dreamer, this phosphorus-nitrogen life could never arise in a world like ours. Our great solvent, water, is its mortal enemy. The polar nature of water, its chemical eagerness, would relentlessly attack the phosphorus-nitrogen bond, a process called hydrolysis. It would snip the beautiful braid apart, link by link. Our river of life would be a river of death for this biology. So once again, we must leave home. We must journey to an environment even colder and stranger than Titan. We need a new solvent, a new river, one that is gentle enough to let this delicate braid survive. The perfect candidate is a substance you know as a pungent, sharp-smelling gas. Ammonia. Let us picture a world, perhaps a rogue planet cast adrift from its star, warmed only by the slow decay of radioactive elements in its core. It is a world of eternal twilight, its only light the distant, indifferent glitter of the stars. The temperature here is so low, perhaps 100 degrees Celsius below zero, that ammonia, a gas on Earth, is now a liquid. There are vast, sluggish oceans of liquid ammonia. Ammonia is a remarkable solvent. Like water, it is polar, so it can dissolve many things. But it is a much gentler, kinder solvent than water. It does not have water's aggressive tendency to tear molecules apart. It would provide the perfect, placid bath for our PN chains to assemble, fold, and interact without being destroyed. An ammonia ocean would be the cradle for a phosphazine-based life. What would this being be like? It would not be crystalline and rigid like our silicon dreamer. The rubbery, flexible nature of its core chemistry suggests something else entirely. Imagine a creature that is more like a gelatinous, flowing current within the deeper currents of the ammonia sea. It might be amorphous, changing its shape, its form defined not by a rigid skeleton but by a dynamic, flowing internal structure. It would be a slow, viscous bloom of life in the silent, frigid deep. Its metabolism would be the slowest we have yet imagined. In this profound cold, every chemical process would be glacial. It might feed on complex chemicals dissolved in the ammonia, perhaps formed by radiation from the planet's core or the faint cosmic rays from deep space. Its version of DNA might be another phosphazine chain, a ribbon of memory where information is stored not in the sequence of 4 bases like ours, but in the sequence of different side groups attached to the phosphorus atoms. Its very thoughts, if we can call them that, would be slow, deliberate ripples of chemical change, taking millennia to reach a conclusion. This is a vision of life that pushes our definitions to their very limits. It is not just the element that has changed, nor just the solvent. The very principle of the backbone has been transformed from a monologue into a dialogue, a partnership between the fiery and the stable. It's a life woven from a chemical braid, swimming in a liquid that would be a poison to us on a world without a sun. It demonstrates that the possibilities of biology might be far more plural, far more exotic than we have dared to think. We have now imagined life on solid ground and in liquid seas. We have conceived of it as crystalline and as gelatinous. But all these visions have been tied to a planet, a world, a solid or liquid surface. What if even that is not a requirement? What if life has found a way to let go of worlds entirely to exist in the spaces in between? Could life exist as a pattern in pure energy, a ghost in the cosmic machine? Section 5. Life in Starlight and Plasma. We have journeyed far, you and I. We have walked the crystalline plains of a silicon world and swum in the dark, cold seas of a methane moon. We have imagined a being woven from a braid of 2 elements, flowing like a gelatinous dream in an ocean of ammonia. But all these strange and wonderful beings, however alien, have shared one thing in common with us. They have all been tied to a world. They have needed a ground beneath their feet or a liquid to buoy them up. They have needed a place. But as you float here, in the boundless space of your imagination, let us untie that final anchor. Let us ask the most audacious question yet. Does life need a planet at all? Could it exist in the vast, ethereal spaces between the stars? Could it be a thing not of matter but of pattern? A ghost in the great cosmic machine? Let your awareness expand, drifting out of the solar system into the interstellar void. You are floating now in a place of breathtaking beauty and impossible scale. A stellar nebula. A cosmic nursery where new suns are being born. This is not empty space, it is a cathedral of dust and gas stretching for light years. It is filled with slow-motion cyclones of hydrogen, shimmering veils of hydrocarbon molecules, and a fine, glittering dust of carbon and silica teeth, very ashes of ancient, long-dead stars. The light from newborn stars nearby illuminates it from within, making it glow with hues of soft pink, deep blue, and incandescent gold. It is a place of profound silence and slowness. Here, time itself seems to stretch and thin. And it is here that we might look for a form of life so vast and slow that we would barely recognize it as living. Imagine a being not made of the cloud, but a being that is the cloud. A sentient nebula. This creature would not have cells or organs or a body in any sense we would understand. Its body would be an immense, organized pattern of dust and gas held together by the gentle, persistent embrace of its own gravity. Its thoughts would not be electrical sparks in a brain, but slow, deliberate eddies in the swirling dust, gravitational ripples that could take 1,000,000 years to traverse from one end of its consciousness to the other. Its metabolism, the process of its living, would be a dance on an astronomical scale. It would feed by drawing in wisps of gas and dust from the surrounding interstellar medium, using its gravity to gently herd them into denser filaments. This is its ingestion. Its respiration would be a delicate interplay with the young, hot stars forming in its heart. The intense radiation and stellar winds from these newborn suns would push back against the gravity, blowing bubbles and clearing cavities within the nebula. This constant, gentle push and pull, gravity pulling in, starlight pushing out, would be the breath of this magnificent being. A cycle of cosmic inhalation and exhalation that unfolds over eons. It would be a cosmic gardener. Its very existence would be to shepherd the birth of stars, to nurture them in its dusty womb. It would feel the universe in a way we cannot comprehend. It would sense the pull of distant galaxies, feel the shock wave from a supernova as a ripple in its own substance, and perceive the birth of a new sun in its core not as a sight, but as a feeling of warmth, a change in pressure, a new voice in the slow, silent chorus of its being. How would such a thing reproduce? Perhaps when a shockwave from a dying star passes through it, a large fragment of the cloud is sheared off, a child nebula that then begins its own slow, gravitational journey towards self-awareness, carrying with it a faint gravitational memory of its parent. It would be a lineage not of genes, but of galactic patterns passed down through the ages. This is life as a distributed network, a slow mind written in dust and gravity. It is a humbling thought that we might sail through such a creature without ever knowing it was there. Our entire history a fleeting spark in a single one of its 1,000,000-year thoughts. Now, from the profound cold and slowness of the nebula, let us journey to its absolute opposite. Let us go into the fire. Let us plunge into the heart of a star. Or, to be more precise, into its seething, incandescent atmosphere. A place of pure, chaotic energy. A plasma. Plasma is the fourth state of matter. It is a gas that has been heated to such an extreme temperature that the atoms themselves have been torn apart. It is a turbulent soup of charged particles, electrons, and ions all writhing in a magnetic field of unimaginable complexity. It is the most chaotic, violent environment we can imagine. And yet, some have theorized it might be precisely the place for a different, faster kind of life. Let's call this being a Solarian, a creature of pure plasma and magnetism. It would not be made of matter in the way we are. Its body would be a complex, self-sustaining, organized pattern within the plasma, held in place by its own intricate magnetic field. Think of a smoke ring or a whirlpool in a river. They are not things in the air or water. They are stable patterns of the air or water. A Solarian would be like theta-stable, intricate knot of magnetic flux ropes, trapping plasma in a coherent living shape. A ghost woven from pure force. It would live and thrive on the very chaos that surrounds it. Its food would be energy. It would feed on the magnetic energy of the star itself. A solar flare, a coronal mass ejection to us, these are events of terrifying violence. To a Solarian, they might be a meal. It would absorb a sudden influx of energy, its magnetic body flexing and reconfiguring to maintain its integrity, growing stronger and more complex. Its senses would be entirely electromagnetic. It would see the flow of charged particles, feel the shifting topology of the star's magnetic fields. Its consciousness would be a lightning-fast dance of electrical and magnetic interactions. Where the nebula being's thoughts took 1,000,000 years, a Solarian's entire life might flash by in a matter of minutes or hours, an impossibly rapid existence in the heart of a stellar furnace. And reproduction? Perhaps when two of these magnetic beings drift into one another, their complex fields could interact, creating smaller, independent magnetic patterns that are then cast off to live on their own. Or perhaps a particularly large solar flare could shatter a Solarian, with each fragment having the potential to reform into a new, complete individual. This is life at its most abstract. Not carbon, not silicon, not even dust. Life as a self-sustaining information processing pattern. It forces us to confront the deepest question of what life even is. Is it the material, the vessel? Or is it the information, the pattern, the organization that persists through time? If a pattern can store information, gather energy to sustain itself, and replicate, does the medium it is made from truly matter? Whether a sentient cloud or a solar ghost could truly exist is a matter of pure speculation. But thinking about them does something profound. It liberates us from our own biological chauvinism. It suggests that the universe may have found ways to harbor complexity and awareness in forms we are utterly unequipped to recognize. The story of life might be written in many more languages than we ever dreamed. We have now seen how different the actors can be and how different the stages. But let us return for a moment to a crucial piece of the scenery we have touched on but not fully explored, the liquid that makes the chemistry possible. We have seen water and methane. But what other cosmic rivers might flow? Section 6. The Cosmic Solvents. In our journey so far, we have found that for every actor on life's stag, be it carbon, silicon, or a phosphorus nitrogen braid, there must be a river. A medium. A liquid dance floor where the molecules of life can meet, waltz, and combine. Life is not a static crystal, it is a flow, a current, a chemical conversation. And this conversation needs a language, a medium to carry the words. On our world, that medium, that universal language, is water. Let us pause for a moment and appreciate the sheer artistry of water. It is a molecule of profound and deceptive simplicity, two small hydrogen atoms clinging to a larger oxygen atom like a child holding each hand of a parent. But this simple shape hides a universe of complexity. As we felt before, water is polar. The oxygen side holds a faint negative charge, the hydrogen side a faint positive one. This makes every single water molecule a tiny, dancing magnet. When they gather together, they form a shimmering, interconnected web of gentle attractions. This polarity is what makes water the universal solvent. It lovingly coaxes apart salts, sugars, and other polar molecules, cradling them in its embrace, allowing them to drift and find one another. It is the perfect host for the party of life. Its temperature range is also a quiet miracle, a wide and gentle smile that allows it to remain liquid across the most habitable zones of our planet. It is the reason we have oceans, not just deserts of ice or continents of steam. Water is the benevolent matrix, the gentle womb in which the fierce and intricate chemistry of carbon was born and nurtured. But is this womb the only kind? We have already visited the frigid, non-polar seas of methane and the even colder, gentle oceans of ammonia. But the universe's pantry of potential solvents is far more vast and strange. Let us imagine other rivers, other cradles for life. Let your mind travel now to our troubled sister planet, a world shrouded in a thick, suffocating blanket of clouds. Venus. Here, the surface is a vision of hell, hot enough to melt lead, with a pressure that would crush you into a whisper. But high above this infernal surface, in the upper atmosphere, the temperature and pressure are surprisingly Earth-like. This temperate zone, however, is not a gentle haven. The clouds here are not made of water vapor. They are thick, swirling banks of concentrated sulfuric acid. Could this corrosive torrent be a river of life? Sulfuric acid is, like water, a polar solvent. In fact, it is an extremely powerful one. It would tear our familiar biology to shreds in an instant. DNA, proteins, fat sol would be violently dismantled. So, if life were to exist here, it would need to be made of something incredibly stern and unyielding. Imagine a biology not based on carbon's usual bonds, but perhaps on fluorocarbon skeins of carbon surrounded by a tough, non-stick shield of fluorine atoms. This would be the Teflon life, a biology utterly impervious to the acid that is its home. These beings would likely be microscopic, aerosolized life forms living their entire existence as tiny droplets within the larger droplets of the acid clouds. Their world would not be a planet with a surface, but a perpetual, floating existence in an acidic fog. They would be children of the eternal haze, their entire universe a cloud. Now, let us leave the violence of the acid clouds and travel to a gentler, more speculative place. Perhaps a young, rocky world still finding its way. Here, we might find pools not of water, but of a different liquid, a substance called formamide. Formamide is a beautiful chemical hybrid. It has some of the polar qualities of water and some of the gentle, reducing qualities of ammonia. It is a jack of all trades. Its true magic, however, is twofold. First, it stays liquid over an enormous range of temperatures from the bitter cold far below water's freezing point to well above its boiling point. It is a solvent for all seasons. But its second quality is even more profound. Formamide is not just a passive stage for life. It can be an active midwife. When heated or when in the presence of certain common minerals, formamide can spontaneously form some of the most fundamental building blocks of life, including the very nucleobases that make up our RNA and DNA. It doesn't just host the party, it helps write the guest list. So, on a world where water is scarce or frozen, one can imagine a sheltered crater, warmed by geothermal heat. In that crater lies a shallow pool of formamide. For millennia, it has been concentrating chemicals from meteorite dust and the planet's own crust, and under the faint light of a distant sun, it is slowly, patiently, stitching them together. Life here might be just beginning, not a complex ecosystem, but the first stirrings of replication, born in a cradle far gentler and more creative than we once thought possible. Finally, let us explore the strangest river of all, one that is not truly a liquid. Under conditions of very high pressure and temperature, a substance can enter a strange state of matter called a supercritical fluid. It is not a gas and it is not a liquid, but a ghostly state in between, a dense fog that has the properties of both. It can flow into the tiniest pores like a gas, but it can dissolve materials like a liquid. Imagine a planet with a tremendously thick atmosphere where the pressure at the surface creates a vast, deep ocean of supercritical carbon dioxide. Life here would not swim, but drift. It would exist in a perpetual, dense, soupy environment that is everywhere at once. Such a creature would not need lungs or gills, for the solvent and the atmosphere are one and the same. It could absorb its nutrients and expel its waste directly through its skin into the fluid that surrounds and permeates it. It might be like a living blimp using tiny changes in its internal chemistry to control its buoyancy, rising and falling through the dense atmospheric layers as if they were ocean currents. It would live in a world without a floor, in a river that has no banks. The lesson of the cosmic solvents is a powerful one. The nature of the river fundamentally dictates the nature of the life that can swim within it. An aggressive, acidic river demands a tough, resilient life. A gentle, creative river like formamide might nurture the very first sparks of biology. A ghostly, all-pervasive river like a supercritical fluid might give rise to a life that seems to us more like a phantom than a creature. Each solvent provides a unique set of rules, a unique context that would shape an alien biology into a form we can barely conceive of. And this brings us to one of the most fundamental processes of all. Whether in water, methane, ammonia, or a ghostly fog. A living thing must do one thing to be considered alive. It must gather energy. It must eat. It must breathe. On Earth, this process is dominated by a single fiery element. But in these other rivers, on these other worlds, how would an alien being power its dreams? What would be its fire? Section 7. An alien respiration. Feel the air as it enters your lungs. A cool, quiet tide drawn in without a thought. And feel the gentle release, a warmth return to the world. This simple, rhythmic act, this breath, is the most fundamental process of your energetic life. It is the act of fanning a fire that burns within every one of your trillions of cells. A slow, controlled, and utterly miraculous fire. The fuel for this fire is the food you have eaten, the complex chains of carbon, painstakingly assembled by sunlight and plants. But a fire needs more than just fuel. It needs an accelerant. It needs a chemical that is hungry, eager to react, ready to tear apart the fuel and release the energy locked inside. For you, and for almost all complex life on Earth, that accelerant is oxygen. Oxygen is a thing of violence and power, a pure and ravenous element. It is the reason a spark becomes a flame, the reason iron rusts into dust. When you breathe it in, you are inhaling the ghost of a fire. Your cells have learned, over billions of years, how to tame this fire, how to harness its power without being consumed by it. They use oxygen to shatter the bonds of sugar and fat, and in that shattering, they capture the released energy, storing it in the tiny, rechargeable batteries of ATP. This is respiration, a constant, controlled explosion that powers your every movement, your every dream. But as we drift in the cosmic quiet, we must ask, is this fiery, oxygen-driven breath the only song of life? Or does the universe hum with other energetic melodies? Life, at its core, is an opportunist. It finds a source of high-energy chemical potential and a low-energy place to dump the waste. It is a system that creates order in itself by harnessing a downhill flow of energy. Oxygen provides a very steep, dramatic hill, a waterfall of energy. But perhaps other, gentler slopes can also be navigated. Let us return to the kind of world we imagined for our silicon dreamer. A world shrouded in a thick atmosphere, but one with no free oxygen. A reducing world rich in hydrogen and carbon dioxide. Here, oxygen's violent breath would be absent. The air itself would extinguish any flame. So how could a creature here light its inner fire? The answer is as elegant as it is simple. It would do the very opposite of what we do. It would breathe hydrogen. Imagine a slow, crystalline being on this dim world. It does not inhale the ravenous oxygen, but the thin, quiet whisper of hydrogen gas. Its fuel is not sugar, but the simple carbon dioxide vented from the planet's volcanoes. Inside its alien cells, a different fire burns. It combines the hydrogen with the carbon dioxide. It is not an act of shattering, but an act of building. It forges methane, and in this gentle act of creation, energy is released. Not in a great rush like ours, but in a slow, steady, persistent trickle. Enough to power a life lived on a geological timescale. This is not fantasy. This is the life of the methanogens, some of the most ancient and resilient organisms on our own planet, hiding in oxygen-free pockets like swamps and the guts of animals. They are a living echo of what a different path for life could have looked like. On an alien world, this might not be a niche strategy. It could be the dominant form of respiration. An entire biosphere breathing in hydrogen and exhaling a methane haze that could, in turn, become the very solvent for another kind of life on a colder world like Titan. One creature's waste becomes another's ocean. The universe wastes nothing. Now let us imagine a different world, one not of gentle whispers, but of fire and brimstone. A volcanic world, like Jupiter's moon Io, racked by constant eruptions, its surface painted in vivid yellows and oranges. The air here is thick with the pungent, acrid scent of sulfur. To us, it is the smell of hell, a toxic warning. But to the life of this world, it could be the very breath of heaven. Sulfur sits just below oxygen on the periodic table. It too is hungry for electrons, though not as ravenously, can play a similar role. Imagine a creature living near a volcanic vent. It does not feed on sunlight, but on the chemical energy of the planet's inner fire. It might take in hydrogen sulfide, the gas that gives rotten eggs their smell, as its fuel. And it would breathe in another sulfur compound from the volcanic plumes, or perhaps even elemental sulfur dust itself as its oxidizer. Its inner fire would be a sulfurous one. It would not exhale carbon dioxide, but perhaps deposit tiny, pure crystals of sulfur as its waste. Its body would be adapted to this environment. Its blood, or whatever fluid it uses, might not carry oxygen, but other sulfur compounds, giving it a strange, yellowish hue. It would be a being born of the volcano, its life a testament to the fact that one organism's poison is another's sustenance. Its entire existence a slow, patient metabolization of its planet's molten heart. From the volcanic, let us go to the geological. Let us imagine the slowest breath of all. On Earth, we see it happening all around us, an act of respiration so slow we mistake it for decay. Rust, the slow, inexorable oxidation of iron. This reaction releases energy. It is a fire that takes years to burn out. Could a living thing harness such a patient process? Again, the answer is written in the deep places of our own world. There are bacteria, so-called iron breathers, that do just this. They live deep in the soil and the seabed, far from oxygen. They take in organic matter as their fuel, and they breathe not oxygen, but iron oxide rust. They transfer electrons to the iron, changing its chemical state and releasing a tiny puff of energy. Now let us transport this principle to an alien world, a planet ancient and rich in metals. Life here might not be organic in the way we think. It might be a true lithotroph, a rock eater. Imagine a creature that looks more like a lichen or a metallic stain on a rock face. It has no mouth. It does not hunt or graze or photosynthesize. It slowly, directly draws its energy from the minerals it lives on. It might take in one form of iron or manganese oxide from the rock and through an incredibly slow internal process use it to metabolize other minerals, exhaling a different metallic compound. It would be a living corrosion. Its life would not be governed by the cycle of day and night, but by the slow, eons-long cycle of geology itself. It would be a being in a slow, patient conversation with stone, its breath a gradual transformation of the very ground on which it rests. Hydrogen, sulfur, iron. These are but a few of the melodies the universe can play. Each breath, each fire, is perfectly tuned to its world. A fast, powerful breath for a world of rapid change and abundant energy. A slow, gentle breath for a dim world where patience is the key to survival. The way a creature gathers its energy is the most profound thing about it. It dictates its pace, its shape, its lifespan, and ultimately its entire experience of reality. And this raises our next question. If a creature breathes sulfur and eats rock, if its mind is a slow ripple in a crystalline body, how would it perceive the universe? What would it feel? What would it see? Section 8. Sensing a different universe. Your reality, as you lie here, is a story being told to you. It is a story whispered by 5 faithful narrators: sight, sound, touch, taste, and smell. The gentle pressure of the blanket against your skin, the distant hum of the world outside, the soft light filtering through your eyelid. These are the words, the sentences, the paragraphs that construct the world you know. Your brain is the patient reader, taking these inputs and weaving them into the seamless tapestry of your experience. This personal world, this sensory bubble, has a beautiful name in science, the umwelt. It is the slice of reality your biology allows you to perceive. A dog with its universe of scent lives in a different umwelt. A bat painting the world with sound lives in another. But each of these worlds, however different, is a variation on a familiar theme born here on Earth. As we drift further into the cosmos, we must imagine senses so alien that they do not just read a different story, but are written in a completely different language. If a creature is made of different matter, bathed in a different liquid, and powered by a different fire, then surely it must perceive the universe through a different window. Let us first shed the sense that you trust most, your sight. Let us close our eyes not just to the room around us, but to the very concept of light. Imagine you are the iron-breathing lithotroph we met, the living corrosion on the face of an ancient, metal-rich world. Your life is not about the sun, but about the slow, deep energy of the stone beneath you. Light is a fleeting, irrelevant flicker on the surface. Your primary sense, the one that defines your entire reality, is magnetoreception. For you, the world is not made of objects and colors. It is a grand, silent symphony of forces. You feel the planet's magnetic field not as a direction, but as a constant, gentle pressure on your entire being. A current you can lean into, a river that tells you where you are. The dense iron core of your planet is not a hidden mystery. It is a warm, deep hum at the very center of your perception, the bass note of your world song. When a solar flare from your distant star washes over the planet, you do not see a shimmering aurora in the sky. You feel it as a sudden, tingling fever in the rock, a shivering ripple through the magnetic field, a storm in the invisible landscape. You would navigate by following the magnetic grain of the land, feeling your way along the lines of force as if they were carved pathways. Other living things would not be shapes to see, but subtle disturbances in the field. A creature burrowing deep in the rock would be a moving knot of magnetic silence. A swarm of smaller metallic organisms would be a crackling static in your perception. You would feel the geology of your world as intimately as you feel your own body. You would know a deposit of iron or not by its color, but by the deep, satisfying resonance it creates within your senses. You would be a creature feeling the very bones of your world. Now, let us allow light back into our minds, but let us see it with new eyes. On Earth, your eyes are brilliant detectors of color and intensity. But there is another property of light that you are almost entirely blind to, its polarization. Polarization is the direction in which a light wave vibrates. Imagine if you could see it. Imagine you are an insectoid creature on a world with a thick, hazy atmosphere. Your multifaceted eyes are not just for color, but for perceiving the texture of light itself. This is polarized light perception. To you, the sky is not just a uniform color, it is a vast, intricate map of patterns. The way the atmospheric particles scatter the sunlight creates a breathtaking, shimmering tapestry that tells you the precise position of the sun even when it is hidden behind the thickest clouds. You navigate not by landmarks, but by this celestial compass woven into the very fabric of the sky. Reflections would not be mere glare. The shimmer off a pool of liquid methane would have a distinct polar signature, telling you about its depth and purity before you even get close. The carapace of a predator, camouflaged perfectly in color, might betray itself by the unique way its shell polarizes light, making it stand out to you like a beacon. You would see the hidden stress in a crystalline plant, revealing its health and structure. Your visual world would have a depth and richness you can barely imagine, a world where light has a grain, a direction, a texture. You would perceive a layer of reality that, to human eyes, is utterly invisible. From this world of textured light, let us now sink into a reality where the very boundary between self and other dissolves. Imagine you are the gelatinous, phosphazine being we envisioned flowing in its ocean of liquid ammonia. You have no eyes, no ears, no nose in any sense we would understand. Your entire being, your flexible, semi-permeable body, is a single, unified sensory organ. Your senses direct chemical communion. You do not taste or smell things in your world. You become them momentarily. When a fellow creature passes by, you don't see it. You feel its presence as it releases a subtle cloud of complex molecules, its metabolic waste, its signaling hormones, its very essence. This cloud drifts through the ammonia sea and permeates the outer layers of your being. In that moment, you are not just sensing the creature, you are experiencing a faint echo of its internal state. You might feel a flicker of its fear as a bitter cascade of stress molecules, or a sense of contentment as a warm, simple chemical signature. Communication would not be a series of sounds or gestures, but a direct exchange of being. To express sorrow, you might release a complex, slow-decaying molecular chemical sigh that lingers in the current. To show joy, you might emit a burst of a simple, energetic compound. It would be a world of radical empathy, a world where deception is nearly impossible because your very feelings are an open book, readable by all who pass through your wake. The concept of an individual, a discrete self, would be much more fluid. Where do you end and the world begin when your perception is a constant process of absorbing and releasing the chemical thoughts of your environment? Magnetism, polarized light, chemical communion. These are just the beginnings. Imagine a being in a supercritical fluid that senses the world through infinitesimal shifts in pressure, a living barometer. Imagine a creature that uses the faint seismic tremors of its planet as a form of echolocation, seeing with earthquakes. Each of these sensory worlds would create a different kind of mind, a different kind of consciousness. A being that feels magnetism may have no concept of past or future, only the constant now of the field. A being of chemical communion may have no concept of I or you, only us. The way an organism perceives reality is the loom upon which its consciousness is woven. And now that we have gathered all our threads, our alien elements, our strange solvents, our exotic breaths, and our new sense, it is time to weave them together. It is time to imagine not just a single creature, but a whole and functioning world. A symphony of other life. Section 9. A symphony of other life. Let us now, in the final stages of our outward journey, become quiet observers. We have gathered the threads of possibility, the silicon atom, the methane river, the hydrogen breath, the magnetic sense. Now, it is time to weave them into a living tapestry. We will not just theorize, we will witness. Let your consciousness drift down towards a world we shall invent together. A world orbiting a small, ancient, orange dwarf star. Let us call it Xylos. From space, Xylos is a thing of subtle beauty. It is not blue and green, but a soft, shimmering lavender, with vast polar caps that glint like mother of pearl. The lavender hue comes from its thick, nitrogen-rich atmosphere, hazy with the methane exhaled by its inhabitants. As we descend, the profound cold greets us, a clean, sharp stillness that feels less like a temperature and more like the natural state of the cosmos. The ground comes into view, a landscape of jagged, ice-hewn mountains made not of silicate rock, but of water, frozen as hard as steel for 1 billion years. And flowing through these ice valleys are the rivers and seas we imagined. They are not blue, but dark, clear, and placid like polished obsidian. These are the seas of liquid methane and ethane, the lifeblood of this world. And growing on the shores of these dark seas and across the vast plains is the foundation of all life on Xylos. The flora. They are not forests of green, but groves of crystal. Imagine a forest made not of wood, but of thought. These are the silica groves. Great, branching structures of pure, translucent silicon dioxide quartz, but grown with the slow, deliberate intentionality of a living thing. They look like immense, frosted glass sculptures catching the dim, orange light of their sun and refracting it into 1,000 muted rainbows. They are not photosynthesizing. The light is too weak. Instead, their roots are fine, crystalline filaments that burrow deep into the water ice bedrock, seeking out geothermal warmth and the chemical-rich veins where the moon's inner heat meets the frozen water. They are chemosynthesizers, drawing their energy from the slow reaction between dissolved minerals, building their intricate, glassy bodies one molecule at a time over centuries. The air around them hums with a silence so profound it feels like a substance. The only sound is the occasional, high-pitched tink of a crystal frond finally succumbing to an internal pressure and snapping off, falling to the ground like a shattered icicle. Now watch closely. Something is moving through the crystal forest. It is a glass strider. This is the primary herbivore of Xylos. It is a creature of exquisite fragility, looking something like a 6-legged praying mantis carved from smoky quartz. Its body is an intricate lattice of silicon polymers, and through its semi-transparent shell, you can see the slow, viscous flow of its internal fluids. It moves with an incredible, patient delicacy, its fine-tipped legs finding perfect purchase on the slippery crystal branches. It does not eat the way we do. It has no mouth for chewing. At the end of its long, elegant snout is a pad that exudes a complex cocktail of catalytic compounds. It presses this pad against the surface of the crystal trees, and for a long moment, it is perfectly still. It is not eating the tree, but rather, it is licking the rich layer of energetic chemicals and dust that has precipitated out of the methane atmosphere and settled on the crystal surfaces. Its many-faceted eyes are not for seeing color, but for perceiving the world as we imagine it, a landscape of polarized light. This allows it to see the stress patterns in the crystal, finding the branches that are richest in the specific mineral dust it needs. To the glass strider, the forest is not a collection of objects, but a shimmering, textured map of nourishment. But the glass strider is not alone. It is being hunted. On a low, flat-top crystal outcrop nearby, a creature lies in utter stillness. This is the field stalker. It has no defined shape. It looks like a patch of mottled, dark gray mineral deposit, a living stain on the landscape. It has no eyes, no ears, no limbs. It is a slow, amoeboid predator, a being of pure patience. Its entire body is a single, unified sensory organ for the planet's magnetic field. It does not see the glass strider. It does not hear its delicate footsteps. It feels it. The silicon-based biology of the strider, with its complex internal flows, creates a minuscule, almost imperceptible disruption in the planet's magnetic field. To the field stalker, this disturbance is a shout in its silent, magnetic world. It feels the approach, the presence, the very life force of the strider as a knot in the fabric of its reality. For hours it waits. The glass strider, unaware, finishes its meal and begins to descend the crystal trunk. As its foot touches the ground near the field stalker's resting place, the predator finally moves. It does not leap, it flows. A section of its gray, viscous body surges forward, extending a pseudopod that envelopes the strider's leg. The strider struggles, a brief, silent ballet of desperation. But the stalker's substance is incredibly adhesive and strong. Slowly, with geological hunger, the field stalker draws the crystalline creature into its mass, where it will be broken down and absorbed over the course of days. It is a hunt of silent, invisible forces, a drama played out in a sensory dimension we can barely comprehend. And what of death? When the field stalker eventually ceases its slow life, or when a crystal tree finally shatters under its own weight, their complex silicon forms do not rot. They are consumed by the final player in this symphony, the silica molds. These are vast, slow-spreading mats that look like a cross between a lichen and a frost pattern. They are the decomposers. They exude powerful solvents that slowly, patiently dissolve the complex silicon polymers back into simpler, inorganic silicates, returning the building blocks of life to the planet's crust. It is a cycle of life as complete and as perfect as our own, but written in a different chemical language. Here on Xylos, life is a slow, silent, crystalline dance. A symphony of chemosynthesis, polarized light, and magnetic fields, all playing out in a theater of methane seas and water ice mountains. It is a world that is utterly alien, yet follows the same deep, universal laws of eat and be eaten, of life and death and renewal. It is a complete and self-contained miracle, a testament to the universe's endless creativity. It exists in our imagination as a perfect, functioning whole. And observing this world, so strange and yet so logical, forces us to turn our gaze back towards the faint, distant star that is our own sun. After seeing all this, after imagining all these possibilities, what does our own existence look like now? What does it mean to be a creature of carbon and water in the face of such cosmic pluralism? Section 10, The Carbon Echo. Let the lavender skies of Xylos fade. Let the image of the crystal forests dissolve like a frost pattern in the morning sun. Allow the feeling of profound cold and the silent hum of magnetic fields to recede, and let your awareness begin its long journey home. Across the light years, past the glowing nebulae and the lonely rogue worlds, you travel back towards a familiar, sun-drenched corner of the galaxy. Back towards a small, spinning jewel of blue, white, and green. Back to Earth. And as you arrive, let your awareness settle not on the grand scale of the planet, but on the intimate scale of your own body. Feel, once more, the gentle weight of the blanket. Feel the warmth that blooms in your chest and radiates through your limbs, a warmth utterly alien to the crystalline creatures of Xylos. Feel the softness of your own skin, a supple, yielding surface so different from the hard, glassy carapace of the glass strider. Listen to the faint, rhythmic drumming in your ears. That is the sound of your own heart, pumping warm, iron-rich, water-based blood. It is a frantic, impossibly rapid pace compared to the glacial existence of the beings we have just left behind. We have returned. And after our grand tour of cosmic possibilities, everything here feels both profoundly familiar and startlingly new. We have returned with the ghost of other worlds clinging to our consciousness, and in their strange, silent light, we see ourselves for what we truly are, a miracle of carbon. We began our journey by calling carbon the quiet architect, the humble sovereign. But now, having seen the alternatives, we can give it new names. Carbon is the element of speed. It is the element of warmth. It is the element of softness. The bonds it makes, so perfectly balanced between strength and fragility, allow for a biology that is not static and slow, but dynamic and swift. The reactions in your cells are happening on a timescale of milliseconds. A thought flashes through your mind in an instant. A wound begins to heal in hours. This is the gift of carbon's unique chemistry, a life lived not at the pace of geology, but at the pace of a rushing river. And that river, of course, is water. We saw the placid, non-polar seas of methane and the gentle, frigid oceans of ammonia. But our water, our wild, polar, energetic water, is the true engine of our world's dynamism. It is the womb of change, the ultimate stage for a frantic ballet of creation and dissolution. It is water's very eagerness to react that allows our carbon chemistry to proceed with such breathtaking speed. We are not slow, crystalline beings because our very substance, our watery core, would not allow it. We are creatures born of a partnership between the most versatile atom and the most dynamic solvent. We are a fever dream of complexity, a fleeting, brilliant flame made of stardust and water, burning brightly on a rocky shore. This journey we have taken, this exploration of life beyond Earth's elements, was not just an exercise in scientific imagination. It was a search for a mirror. We journeyed across the cosmos, peering into the dark, hoping to see a different face look back at us, to hear a different voice answer our call. And what have we found? In the real world, beyond our shared dream tonight, we have found only a profound and magnificent silence. The radio telescopes listen and hear only the whisper of quasars and the ancient hiss of the Big Bang. The probes land on dusty red plains and hazy orange moons and find only chemistry, beautiful and complex, but not yet alive. This silence can feel like a lonely thing. It can make our warm, blue living island feel small and isolated in the vast cold ocean of the cosmos. Where are the silicon dreamers? Where are the sentient nebulae? Why is the universe so quiet? This is the great question, the Fermi paradox, that haunts the waking minds of scientists. But here, in the peaceful space of sleep, we can choose to interpret that silence differently. Perhaps the silence is not a sign of our cosmic solitude, but a measure of our cosmic preciousness. Perhaps life is not a common weed springing up in every available crack in the universe. Perhaps it is a rare and exquisite orchid, a thing of such delicacy and improbability that it has bloomed here, and perhaps only here. If that is the case, then everything about you is infinitely more wondrous. The simple, rhythmic act of your breathing is not a trivial biological function. It is a defiance of universal odds. The warmth of your body is not just a metabolic byproduct. It is a beacon of impossible complexity in a cold and simple cosmos. Every beat of your heart is a note in a symphony that may be the only one of its kind. The search for alien life becomes a sacred act, for in searching for the other we have found the echo of ourselves. We looked for silicon, and in doing so we finally appreciated the swift, flexible genius of carbon. We imagined methane seas, and we understood, at last, the wild, life-giving magic of water. We conceived of a mind that thinks in magnetism, and we felt the astonishing gift of our own fleeting, conscious thoughts. You are the universe's way of experiencing softness. You are its way of feeling warmth. You are its way of dreaming for a brief and shining moment before returning to the quiet stardust from which you came. You are not a mundane occurrence. You are a carbon echo in a silent universe, a testament to the fact that even in an ocean of probability, the impossible can sometimes happen. You are a rare and precious thing. And now our journey is at its end. We have traveled to the farthest reaches of imagination and returned home, to the quiet and familiar sanctuary of your own being. The questions we have pondered tonight will continue to drift in the cosmos, waiting for answers. But for you, the time for questioning is over. The time for rest has come. Let the wonder of it all settle deep within you. The wonder of the stardust in your bones, the ancient ocean in your blood, the fire of a star in your breath. You are a living piece of the cosmos, a rare and beautiful consciousness cradled on a gentle world. There is nothing more you need to do, nothing more you need to figure out. You are simply here, and that is more than enough. Let the weight of your body feel heavy and safe. Let the rhythm of your breathing be your anchor, pulling you down, down into a deep and peaceful sleep. Sweet dreams, and may your rest be as profound as the universe we have explored together. Good night.